Hi everyone, welcome to the channel DeVOPS-TECHSTACK. So today we are going to start with the day 8 of the Kubernetes series. And in this lecture, we will dive into a super useful Kubernetes concept called as DaemonSets. So you can think of them as a special controllers that make sure a specific type of pod runs on every single worker node on your Kubernetes cluster or on a selected group of nodes. Depends on your situation basically. Okay. So, what is basically your DemonSet? So, imagine you have a task that needs to be present on all the servers, like a security scanner or some logging agent. So, a DemonSet ensures just that it deploys one pod for a given application to each eligible worker node. So, if a pod gets accidentally deleted, the DemonSet controller immediately brings it back. So it's basically about the presence, not scaling the number of pods on a node, but it will make sure that a single pod of that daemon set runs on every worker node assigned to that particular group, basically. Okay. So you can't say that I want three logging pods on a single node. It is always one node by default. Okay. Let's say you have created a daemon set for a logging agent where it is collecting logs from different components. Okay. So in that case, that logging agent pod will be deployed on all the worker nodes, but it will be only one pod. It is not about the scaling. Multiple pods will not run for a single daemon set, only one pod per worker node. And that to worker node, you have to define that on which group of nodes you want to deploy that daemon set. Otherwise, by default, it will be deployed as a single pod on all the worker nodes. This is what I am telling in this particular slide. Okay. Now coming to the next, what are the real use cases where this daemon set comes into picture? So the first criteria is, let's say you have a scenario where you want to collect the cluster log. So ever wonder how all your application logs get collected? So like you have tools like Fluentd, Logstash or Fluentd. So they basically runs as a daemon set. Means a single pod runs on all the nodes which is responsible for collecting the logs. Okay. Now, other scenario might be the cluster monitoring. So you might have heard about the Prometheus monitoring tool. So how that Prometheus works on your Kubernetes cluster. So that also is deployed as a daemon set. Often a node exporter which runs as a daemon set on every node. It is collecting the metrics like CPU usage, memory, disk space, and we are exposing them to the Prometheus to scrape those. So this is another scenario where daemon set comes into picture. The third scenario can be security and compliance. Let's say you want to run a security checks to deploy a detection system on each of the server. In that case, you can deploy that security agent in form of DaemonSet on all the nodes. So DaemonSet will take care of that part. Okay. Now let's say you have one scenario where you want to provision some kind of a storage, chef storage you want to provision. So in that case also you can go with the DaemonSet and that Chef pod will run on all the nodes to make sure that your storage is being shared by the entire cluster. Then we have the network management. Many container network like Calico, they run as a daemon set and they install the necessary networking components on each of the nodes for the pod communication. Because as you know, that within the cluster pod can directly communicate through the local host. So how that networking is established? So using these networking tools like Calico, this networking is established on your Kubernetes cluster and Calico is deployed or as a daemon set on all the workers, right? So this is basically the architecture what I'm talking about. The first is the control plane component. Here your all master components will run. Then you have multiple worker nodes, right? And where your application pods are running. Let's say you have created a daemon set for the cluster log collection, maybe. Then in that case, that will be deployed as a daemon set pod on all the worker nodes, and it will be just a single pod, not more than that. Again, if you want to restrict that, I don't want to create this daemon set pod on all the worker nodes, but still I want to create based on some node selector or node affinity or priority class or 10 time tolerations. These things I will basically discuss in the later lectures because I have not gone through these topics yet. But if you want to restrict that my DaemonSet pod should run on only few nodes, not all the nodes in my Kubernetes cluster, so those configurations can also be done using these particular objects or using these particular concept in the Kubernetes cluster. Okay. So this is basically the architecture of my DaemonSet. This is a simple YAML file which is creating a DaemonSet for the Fluentd. What is Fluentd? Fluentd is again a tool which is available for the cluster log collection. It is basically collecting the logs for your different application pods which is deployed on your Kubernetes cluster. It will collect the logs from those application pods. So it needs to be deployed as a daemon pod on all the workers. This is a simple YAML file where I'm creating a daemon. Again, the concept will be same what we have discussed in the previous lectures, how to create a pod or deployment or replica set. So the concept is again same. The very first is the API version that you already know what type of object you are going to create. The next is the kind. Here we are defining that daemon set we want to create, and this is the API version for the daemon set. This you can refer in the official documentation. Then next is the meta data about the daemon set basically. So the name of my daemon set is Fluentd. In which namespace I want to create this daemon set? I want to create it under the logging namespace. So in your cluster, you need to create, the very first thing is that you need to create a namespace with the name logging. What is the label assigned on my daemon set? So the label is key value is app, value is Fluentd logging. Again, in the specification section, you need to specify what is the particular specification for or configuration for my daemon set. The very first is that the daemon set will manage only those pods which are having the label assigned as name Fluentd. So only the pods which are having this particular label, those will be managed by this particular daemon set. Now comes the template. Under the template section, you will define the section about the pod basically. Again, what is the data about the pod? So on the pod, I have assigned the label as name Fluentd again because these pods are going to be managed by this particular daemon set. So the label on this particular pod need to match with the label under the selector section of the daemon set. Under the spec section, you are defining the configuration or specification about your pod. Pod is basically the container. Under that container is running, so you need to specify that your container is going to use which image. So I am going to use the image, this one. Okay, for the Fluentd, you can refer to the official image site, and this is your registry QUAY. This is the registry from your Fluent, from where basically the Fluentd image will be pulled. Okay, and the name of the container is Fluentd Elasticsearch. So this is the overall YAML file that is responsible to create a daemon set. But once this is applied, so whatever the worker nodes are there on your Kubernetes cluster, if there are two worker nodes on your Kubernetes cluster, two DaemonSet pods will run. Because till now we haven't applied any selector or taint or tolerations. Those things we have not done. So let's go to your Kubernetes cluster and we will apply this particular YAML file. Okay. Just copy this part. This is my cluster. I will just go inside that directory. Okay. The very first is that you need to create a namespace called as logging, right? Then you hit kubectl get NS and you have created a namespace with the logging name, right? Now you need to just first see how many nodes are there on your cluster. So you have basically two worker nodes in your cluster, and then you can apply this particular file basically. Okay. This is done. Okay. So my daemon set has been created. If you see kubectl get pods -n logging, so it is basically creating these particular pods. And it is pulling for the first time on the worker nodes that particular image. So it will take some time to pull the image. So let's wait. And again, if you do -o okay, so it will show on which particular worker node this particular pod is assigned. So you are seeing, right? The pod is assigned to both the worker nodes, one pod of this daemon set to both the workers. But in case you want to assign to only one node, then in that case, you can go with the configuration of the node selector that we will do now only. Okay. But just wait for some time. Okay. Now it is up and running, right? So this is the overall concept of the daemon set, how is it going to be created. Now let's see the concept of the node selector. So while daemon sets can run on every node by default, sometimes you only want them on a subset of your nodes. For example, maybe you have a dedicated platform tool nodes for things like ingress controller or monitor. Okay, so in that case, only on those particular nodes you want to run your daemon set, not on all the worker nodes what are available in your Kubernetes cluster. Maybe it's 50 nodes or 100 nodes. You don't want to deploy that daemon set on all the nodes. In that case, you can go with the configuration of the node selector. So very first thing is you need to label the node. Okay. So if you have two nodes over here, right? In my cluster, I have two nodes, two worker nodes. So if I want to run that particular daemon set pod on only this particular node, let's say, right? So in that case, I can go with the node selector. So how to assign label to the node? For that, you have the command kubectl label node, whatever the nodes you want to label for so that you can deploy the daemon set pod be there. So in that, you can give the node name and then you can give some key value pair over here. Okay. So let's say kubectl label node and then this is my node, right? On this, I just want to run. Okay. And then key value. Key is type anything is fine. Okay. Okay. Then platform hyphen tools. You can give any key value that is up to you. And the same you need to use in the YAML file basically after that. So my node is now labeled, right? Now what is the change in your YAML file? If you want to run that DaemonSet pod only on those nodes which is having the label as type equal to platform tools, so for that you have to do this particular configuration. Everything is same. Just in the spec section of your pod, you need to give this node selector flag, and inside this node selector, you have to give the same key value what you have assigned to your node. So just copy this and we will apply. Okay. And now if you see kubectl get pods hyphen n and then log, right? So if you see now only one Fluentd pod, DaemonSet pod is running, the other one is deleted because you have mentioned in your configuration that I want to run that DaemonSet pod on only those nodes which is having the label this one, right? So the other worker node it was not having this particular label. So from there, DaemonSet automatically remove that particular pod. So these things are being taken care by the DaemonSet controller itself. You don't need to worry about those parts. Whatever the configurations are there in the YAML file, these things will be looked upon to, and the DaemonSet controller will take care of this part. I hope now you are clear with the concept of the DaemonSet. Apart from that, there are many other concepts which we are going to talk slowly. But for now, just practice on the DaemonSet. Thank you for watching our videos. Keep subscribing to the channel DevOps TechStack. Thank you.